Alright, we're going to chat today about adding mixed numbers. Not a super difficult concept, but it does extend what we've done already. It may involve changing our denominator so that we have the same denominator. It may just be a couple extra things. So an example, that's a great way to start with an example of a mixed number. We'll define it in a minute here, but let's, there we go. For example, 2 and 2/3 is a mixed number. Now, how would I show that? Well, I've got these three bubbles here. If I'd shade two of them in completely, that represents my whole number. You can see my mouse coloring is just fantastic. Oops. If I was doing this by hand, I could stay within the lines. And then we have to divide this into three equal pieces, or they're supposed to be anyways, and I shade in two of them. So I have two wholes, right, two complete circles, plus 2/3 of a circle. Okay, so a mixed number is simply, right, we started with the example of 2 and 2/3. A mixed number is simply a number that consists of a whole number, oops, spell it right even, whole number and a proper fraction. Proper meaning, of course, that the top number, the numerator, is bigger than the bottom number, the denominator. All right. So let's talk about adding these things. All right. So we've got an example here: 1 and 5/6 plus 1 and 5/6. So let's draw it out or make our diagram. Right. So I've got 1 and 5/6. So I'm going to start actually, because I can divide this into thirds fairly well, and then just divide each of these pieces in half yet. A bunch of little triangles here, so 1 and 5/6, so 1 complete and 5/6 of another. And here's another complete, so this is my second 1 and 5/6 that we're starting. And these will just get worse and worse, I am sure. Alright, we're assuming these triangles, or pie-shaped things, are all very close to the same size in reality. Alright, so we got 1 and 5/6 plus 1 and 5/6. Lovely. So, well, let's draw out what we have when we add them up. We've definitely got two wholes, right? Two complete ones. So one is going to go there. Yeah, so that's supposed to be an arrow, right? So one of them comes here. Lovely. And another one comes here. Lovely. Alright, so I've added my whole numbers together. And now there's a couple different ways I can think about this second part when I'm starting to add the fractions. I can think, well, 5/6 plus 5/6. I can use my same rules from before and just add the numerators, and now I have 10/6. Now, can I fit 10 of these little sixths into one of these circles? No, I can only fit 6. So, well, let's draw this guy out. So I got 6/6 will go into here. This is probably the easiest way to think about it. Right, so all 6 of these are filled up, shaded in. And over here, you can shade them in neater than I can, I am sure of that. But, ooh, I'm getting adventurous here. Lovely. So I've got 6/6 here, and right, 5/6 plus 5/6 would be 10/6. So I need 10 more. No, I need a total of 10. So I've got 6, 7, 8, 9, and 10. So when I add 1 and 5/6 plus 1 and 5/6, what do I end up with? Well, I wouldn't write 2 and 10/6. It wouldn't be wrong, but it would definitely be confusing. how many complete circles do I have shaded in? I have 3 complete circles shaded in. So I've got 3 and something here. 3 and 1, 2, 3, 4 sixths. Now I got to think, oh, can I simplify that fraction? Yes, I can. Now, when I do the simplification bit, it's only the fraction. I'm not dividing the whole number. The whole number stays as it is, right? We've simplified the whole number by getting rid of this 6 sixths. So 3 is as simplified as that gets. But the 4 sixths part, I can divide top and bottom by 2. And you can sort of see this, hopefully from my picture, maybe more clearly from yours. This is going to be 3 and 2/3. Lovely. All right. So that is definitely a valid way of doing this. Even if you don't use the diagram, right? 1 plus 1, oh, that's 2. 5 6 plus 5 6 is 10 sixths. So I've got 2 and 10 sixths. And now let's just make that into a proper number, right? 6 sixths, so that's another whole, so it becomes 3. And then I've got 4 sixths left over, and away I go. So that's one way to do this, okay? We've got another way. The second way is I can change this to an improper fraction, right? So I can say, okay, you know what? I can even learn how to talk. In spite of what we've got here, 1 and 5 sixths plus 1 and 5 sixths, I can change it, both of them, to an improper fraction. So if we remember how to do that, we've got 1 times 6, that's 6, plus 5 is 11. So I've got 11, and the bottom number stays the same, 11 sixths. That works out nicely. For this one, they're both the same, so it's going to be plus 11 sixths. But again, changing this, it's 1 times 6 is 6, plus 5 more is 11. Now I add my top numbers. 11 plus 11 is 22. I leave the bottom number the same. 22 sixths. Now, because we started with mixed numbers, we got to end with mixed numbers. So now I look and say, okay, 6 goes into 22 how many times? Well, 6 times 3 is 18. 6 times 4 would be 24. So it's going to go 3 times, because 24 is bigger than 22. So 6 times 3 is 18. So 3 times. And how many are left over? Well, 22 minus 18 is 4. So I've got 4 out of 6 left over, 4 sixths left over. Now you've got exactly the same numbers we came up with up there. And now we just simplify our fraction. Now, guaranteed, this might be something you haven't seen for a little while, this whole changing a improper fraction into a mixed number, because this is something we would have normally covered near the end of the year in grade 6. And for those of you who remember last year, the end of grade 6 ended up being a lot of COVID stuff, and so this is one of those little areas that got skipped. So we'll look at this same technique a few more times here yet. So let's take a look at example number 2. All right, so example number 2, we've got 1 2/3 plus 1 2/3. So this one here, we're going to do this 2 ways. I will do the improper fraction method, but I will also show it using just the numbers, but with no diagram this time. So I look at first my whole numbers. So this is really the same as, let me draw this, write this out a different way. 1 plus, I'm really showing extra work here to try to make this, 1 1/3 is the same as 1 plus 1/3, plus 2 plus 1/3. Right, now I can rearrange this. Right, we've talked about the fact that our addition and subtraction in the past are different in some ways, and in this case, one of the ways they're different is that the order we do things with in addition doesn't matter. So whether I go 1 plus 1/3 plus 2 plus 1/3, or 1 plus 2 plus 1/3 plus 1/3, doesn't matter. Now it sort of starts to become a bit easier, right? 1 plus 2, well, that's 3. And we've got plus 1/3 plus 1/3. Hey, I can do that real quickly. 1 plus 1 is 2, and the bottom number stays the same. So I've got 3 plus 2/3. Hey, I can write that as a mixed number. It's 3 and 2/3. Lovely. Now, I can also do this one another way. I'll be honest with you, that is the easiest way. That's kind of the way you want to look to see if you can do that first. Because in this case, my fraction plus my fraction give me a proper fraction, right? I'm not turning that proper fraction into something improper. So in this case, this is probably the easiest way. But maybe you want to do improper fraction stuff all the time. Well, 1 times 3 is 3, plus 1 more is 4. So change the first one to an improper fraction. That's 4/3. Plus 2 times 3 is 6, plus 1 is 7. So it's 4/3. That is supposed to be a plus sign right there. It's sort of a scribble. Let's try to make it look like a plus sign. There we go. Lovely. All right, so here we go. 4 plus 7 is 11. Bottom number stays the same. All right, 3 will go into 11 how many times? Well, it will go into 9 3 times exactly. It will go into 12 4 times. So it's going to have to be just 3 complete times. And how many are left over? 2 left over. 3 and 2/3. Okay, lovely. All right. Your turn. Some of you, this is making total good sense. Some of you, it's a little bit tricky. So I want you, if you're thinking this makes pretty good sense, pause it right now. Give this one a try, example 3. If you're not quite sure, follow along for this one, and I'm going to turn you loose on example 4, but I'll warn you, example 4 is going to require that you find a common denominator. So example 3 is a bit easier. So let's take a look here and let's see what we can do. Okay, so pause it, and let's give this a try. I'll show an answer here. Okay, so I've just rewritten this, adding my whole numbers, adding my fractions. So I'm going to have 3 plus 3/3, but 3/3 is the same as 1 whole, so really I've got 4, my final answer. Okay. Frankly, we could do this mixed number-wise. We might as well. I would recommend this not be the way you do this one, but you can if you want. 1 times 3, that's 3, plus 2 more is 5, so that first one changes to 5/3. Plus, well, 2 times 3 is 6, plus 1 is 7, so 7/3. I add those two together, 5 plus 7 is 12. This stays the same. Look at this, and really remember what a fraction means is 12 divided by 3. Well, 12/3. Hey, wait a minute. 12 divided by 3, that's 4 exactly. Beautiful, I'm done. All right. Moving on to this one here. And 2 ways, again, we can do this one. I can use my first method of adding the whole numbers and then adding the fractions. Either way, though, I am going to be having to find a common denominator for the fractions. So method 1, 1 plus 1. All right, we rewrite this as 1 plus 1 plus 2/3 plus 3/4. Okay, so this is going to equal 2 plus, now I've got the fractions to add. Now this is exactly what you've already done, right? 2/3 plus 3/4. Okay, I'm going to have to find a common denominator. Common denominator of 3 and 4. Right, I can count by 3 is 3, 6, 9, 12. Count by 4 is 4, 8, 12. Perfect. Or I can say, hey, I'm going to multiply both by the other. So multiply this by 4 over 4. Either way, I'm multiplying 3 times 4 because that gives me 12. I'm multiplying the 4 at the bottom here times 3 because that gives me 12. And then I got to do the same thing on the top. So this is equal to 2 plus 8/12 plus, oh, that was fun, 9/12. So this is going to be 2 plus 17/12. Now that's goofy. We've got a whole number plus an improper fraction. So I got to go, well, okay, hold on a minute here. I can take 12/12 away from this and add that onto here. So this is going to be equal to 3 plus 5/12, so 3 and 5/12. Lovely. Now, I could also do this the improper fraction way. All right, so that's method 1. Method 2, here it comes. I'm going to just show this up here on my screen. You probably have more room on your page, but I write pretty big here. So 1 times 3, that's 3, plus 2 is 5, so I've got 5/3, plus 1 times 4 is 4, plus 3 is 7, 7/4. Same thing here. I got to change the to have a common denominator. So 3 and 4, again, same argument as we'd have down here. It's going to end up being 12 as our common denominator. So this one's got to get multiplied both top and bottom by 4. And this one, top and bottom, have to be multiplied by 3. So this is, we've got 20/12 plus 21/12, which is equal to 41/12. Now we got to do a little bit of division. 12 will go into 41. Well, let's see here. 12 goes into 36 3 times, and 41's just a bit bigger than that, so that sounds pretty good. 3, and how many are left over then? Well, 41 minus 36, that's 5. 3 and 5/12. Right. And that takes us to the end of our video and the beginning of your assignment, which is not showing up on my page here, but it is in your book. So, good luck, have fun. I've got 2 days worth of assignments here, right? So there's a day 1 assignment for you guys to work on today. I will talk about this with you tomorrow on Tuesday. We'll go through some of the questions from day 1, and then you've got the day 2 stuff to work on as well. Thanks.